Hello students, welcome to Competitive Exam Library YouTube channel. Today we are going to see what are the questions given in third and fourth module. See 3, 4 and 5 we will continue in this video. A single phase transformer working at 0.8 power factor has an efficiency of 94% at both 3/4 full load and full load of 600 kilowatts. Determine the efficiency at half full load comma unity power factor. So he is asking, so this is somewhat different question. So first step is somewhat different. So if you observe, if you read this entire question, you don't have any the rating of the transformer. So first of all you have to find what is the rating of the transformer. So let us find the transformer rating. So for that purpose it is given the full load of the transformer, that is given in kilowatts, that is 600 kilowatts. But normally we will see the rating of the transformer is in kVA, but it is given in kilowatts. The rating which is given is load. Okay, so now we will find what is by, and the power factor is given. What is the power factor is 0.8. So we already know we have a relation power factor is kW by kVA. Let us find what is the kVA, that is the full load kVA, that is the kVA rating of the transformer, that is kW by cos phi. So what is the kW? Here it is 600 divided by 0.8. If you are going to get 750 kVA. So this is the full load kVA of the transformer. So you have to find what is the, see it is not given the efficiency. So first you have to find what is the efficiency. It is given 94% at 3/4 of the full load. So first of all I am writing, so 94% at x is equals to, that is 3/4 of full load, 3/4 of full load. So you can substitute your efficiency formula, that is 0.94, that is efficiency, 3/4 into 750 kVA, that is full load kVA of the transformer, and the power factor which is given, the power factor will be, what is the value? It is 0.8. So 0.8 divided by 3/4 into 750 into 0.8, the same thing. W iron losses, but copper losses will become x square, that means 3/4 whole square into WCU. So if you do this, so first of all you have to do 3/4 into 750. I am bringing this term on this side, 0.8 plus Wi plus 9/16 WCU, that is equals to 3/4 into 750 into 0.8 divided by 0.94. So if you do this answer, you are going to get what is the exactly values. Here it is. So if you do that answer, you are going to get 478.72 kilowatts. Here, so you have to substitute. Here it is Wi plus 9/16 WCU, that is equals to 478.72. Bring this entire term on the right hand side, so that will be equals to 450. So subtract, then you will get Wi plus 9/16 can be written as 0.56 into WCU, that is equals to finally 28.72 kilowatts. Okay, that is the total losses from the first given information. Take it as first equation. Second equation you are going to get, the second term will be, that is same 94% at full load also, that means x is equals to 1. So let us substitute that 0.94, x is that is 1 into 750 into 0.8 is the power factor divided by 750 into 0.8 plus Wi plus x square will become, x is 1 here. So you are going to get WCU only. So if you do this, you are going to get Wi plus WCU. What is the answer you are going to get? That will be is equals to 38.29 kilowatts. So now you got the equation number 1 and equation number 2. Solve for iron losses and copper losses. So if you solve, I am writing here, solve equations 1 and 2. Then what you are going to get? Iron losses you are going to get it as approximately, that is 16.54 kilowatts. Okay, Next, copper losses you are going to get it as approximately 21.75 kilowatts. Now you got copper losses and iron losses, we are separated. Now we have to find the efficiency at, so full load, half of the full load, that means X is equals to full load, and the power factor is unity. So unity power factor. At this case you have to find the efficiency. Let us write that half into 750 into power factor is given as 1 divided by half into 750 into 1 plus iron losses you got 16.54 plus copper losses will become 1 by 4, that is 1 by 2 whole square into 21.75. So if you do this answer, you are going to get the efficiency will be 94.48 percentage is the efficiency of the transformer at full load, that is half full load, unity power factor. So very simple problem. This is given from the third module. So let us move to the next problem. So this is also, if you observe my videos, this is I already solved, which is a repeated question which was given in 2019. So regularly visit my videos so that you can understand so what is the concept of solving of the problem. See, this is the question is given, a 4-pole DC shunt generator. So whenever you have the type of the generator it is given, so you have to draw the type of the generator what it is given. Shunt generator means like this. So you will get the idea how to write the formulas. So first of all you have to do the step is you have to draw the type of the shunt generator. So I am drawing here type of the shunt generator. After this you have to identify here, there will be EG will be there, after this IA will be there, then after this you will have that is ISH will be there, next you will have IL. So and you will have the terminal voltage will be V here. So this is the shunt generator information, so which is very useful. Next you are having RSH here, next you will have RA here in the armature also. So this is the given information. Now let us write what is the information is given for you. Let us write that given information. A 4-pole, that means number of poles are 4 here. DC shunt generator with lap connected. Lap connected means here you have to remember A is equals to P, that is equals to 4, has field resistance and armature resistance. That means RSH value is given as 50 ohms. Next armature resistance is given as 0.1 ohm. Okay. So which is given information I am writing here. Next it is supplies. So what is the load? Load information is given as 100 volts, that means the terminal voltage. Next 40 watts bulb, like this bulb it is having 60 units. So it is number of units are 60. So what is the power consumed by the total power consumed by the load is, we can write 60 into 40 watts, that is 2400 watts, that is 2400 watts is the load it is consumed. Now you can another information what it is given. So he is asking the brush drop, it is given as 1 volt per brush. That means totally you will have 2 brushes, 2 volt we can consider total brush drop. He is asking what is the total armature current. Say total armature current, if you apply KCL at this node, so IA can be written as IL plus ISH. So first of all we will calculate what is the ISH. So ISH is equals to V by RSH. So ISH value is how much? Sorry, V value is 100 volts it is given. RSH value is given as 50 ohms. That means the current is ISH value is 2 amperes. Next, IL value you have to calculate. IL value, for IL value you have to take here V into IL, you got it as 2400. So IL value will become here V by 2400 divided by, it will become 2400 divided by V. So that means 2400 divided by 100. So it will get cancelled, that is the 24 ampere. So total armature current we can write as IL plus ISH, that is IL value is 24 you got, ISH value is 2, that is 26 amperes is the final answer. Second question, what is the second question it is given? So total armature current in each path, actually it is each path it is given, but I don't know whether they will give the marks or not, but the previous question paper was given correctly. Current in each armature path has to be given, but in each armature conductor. Armature conductor is wrong because we cannot have any information about the flux, speed and all those things. So you can't find the armature conductors, number of armature conductors. So it should be number of current in each parallel path. So current in each parallel path. So here how many parallel paths are there? Here you have A is equals to 4. So IA divided by A, that will be 26 divided by 4. So you are going to get, your answer will be 6.5 amperes. That is the answer for this. Third question is, so what is the generated EMF? EMF generated will be EZ is equals to V plus IA RA, and also it is given brush drop. You have to consider the brush drop also. V is given as 100 volts, IA you got it as that is 26 into 0.1 is the armature resistance plus brush drop will be 2. So 100 plus 4.6, that is 104.6 volts is the total EMF generated. So very simple question which is given, repeated question this one, right. Next we will see the next question. So a 4 pole 220 volts, a 4 pole 220 volts, I will read the question here, give me the time, somewhat big question here. 4 pole 220 volts lap connected DC shunt motor has 36 slots, each slot containing of 16 conductors. It draws a 40 amperes from the supply. The field resistance and armature resistances are 110 ohms, 0.1 ohms respectively. The motor develops an output power of 6 kilowatts. The motor develops an output power of 6 kilowatts. He is asking that. Then the motor, the flux per pole is 40 milliwebers. Calculate the first question is he is asking what is the speed. What is the speed he is asking. Second question is the torque developed by the armature. Third question is the shaft torque. Let us see this question. This is also one of the repeated question, whether you believe or not. You can check my videos. We are already solved this question also. Once again see how to solve this type of model. See how it is given here. So a DC shunt motor. So whenever it is given a type of motor, first you draw the type of the motor. Shunt motor means here once again the you can see like that shunt generator only. Difference is the input you are changing here. So right hand side the input is giving is electrical supply here. So what is the change you can observe here in case of the this shunt generator. Here the applied voltage V here, then you have the line current that will be divided as armature current and the field current, that is shunt current, and here you are having RSH, here you are having the back EMF, and here you are having the armature resistance. Let us write the given information in the problem. So a 4 pole, that means the number of poles are is equals to 4. Next 220 volts, the terminal voltage, that is the supplied voltage is 220 volts. Lap connected means A is equals to P, has 36 slots. Here you see 36 slots and each slot is consisting of 16 conductors per slot. So that means if you multiply this slots will get cancelled. So finally you are going to get total number of conductors. Here it will be, you are going to get the total number of conductors. Here it will be, that is equals to, you have to multiply 20 into, that is how much, 36 into 16, 36 into, keep it like that only, we will see calculation maybe reduces. So and draws a current of 40 amperes, that means the line current is given as 40 amperes, a line current is given as 40 amperes here. Next it is given as what is the another thing it is given. So resistance, the field resistance, that is RSH is given as 110 ohms. Next armature resistance is given as 0.1 ohms. Next the output power is given as in kilowatts, that is output power is 6 kilowatts. So this is the flux per pole is given as flux is 40 milliwebers, that is flux is 40 milliwebers. This is the given information. Let us find the speed. So for the calculation of the speed, you have to calculate the first back EMF. So back EMF formula will be, you know already, V minus IA into RA. So here I know what is the V and RA also, I don't know IA. So let us find what is the IA value? IA is equals to here IL minus ISH. So, ISH will be V by RSH. So, that will be V value is 220 divided by RSH value is 110, that is 2 amperes. Next, IA value is here 40 minus 2, that is 38 amperes. So, you got IA value got. Now you can calculate back EMF. Back EMF is equals to 220 minus, that is IA value is 38 into RA value is given as 0.1. So, if you do that answer, you will get 216.2 volts. But we do not require this back EMF, we require the speed. So, back EMF we are already know the formula will be phi n z by 60 into P by A. P by A will get cancelled because it is a lap connected. Then speed can be written as 60 into EB divided by 60 into EB divided by phi z. So, let us find the speed, that is 60 into back EMF, you got it as 216.2 divided by flux per pole is 40 into 10 to the power of minus 3 and the number of conductors are 36 into 16. If you do this answer, you will get the speed will be, that is 563 rpm, 563 rpm, that is the speed of the motor what it is rotating. Next question, second question, the torque developed by the armature. So, you already know formula, the torque developed by the armature is 0.159 into phi z IA into, that is phi z into IA into P by A. So, P by A here it will get cancelled. So, no need to write that. So, 0.159 flux per pole is 40 into 10 to the power of minus 3 and number of conductors is 36 into 16. Next, armature current is, how much armature current you got? 38. So, you have to multiply all these things, then you will get the answer will be 139.20 Newton meter. Next, third question is, so the shaft torque. See, the shaft torque we are already know, that is P output divided by 2 pi n divided by 60. So, output power is given as 6 kilowatts, 6 into 1000 into I am multiplying 60 also, bring this 60 to numerator here. So, divided by 2 pi, how much speed it is rotating, that is 563. So, if you multiply this, you will get the answer is 101.768 Newton meter, that is the shaft torque or the output torque. This is the simple question which is given once again the repeatedly this question is asked. You can see in I think so 2020 this question was given, in 2020 this question is September 2020, you can see this question, right. Next question we will see. So, this is the last question of the paper, so which is given in the external exam. So, you can see your answers. See, a 6-pole 3-phase star connected alternator, a 3-phase 6-pole star connected alternator has an armature resistance, armature with 90 slots and 12 conductors per slot. It revolves at 1000 rpm. The flux per pole is being 0.5 webers. Calculate the EMF generated if the winding factor is 0.97. All the conductors in phase in series, the coil is full pitch. See, this is the very simple problem which is also a repeated I think so. So, I did not see whether it is repeated or not, but see the solution for this, how to solve this type of problem. See, this is the question is given a 6-pole, okay, number of poles are given as 6 poles. Next, it is a 3-phase supply, a star connected, okay, a star connected alternator here. Next is has an armature resistance and armature of 90 slots. So, total find the number of conductors here. So, we can find the number of conductors here, it will be that is equals to Z is equals to, we can write 90 into, that is into 12, that is equals to 1080. So, total number of conductors are 1080. Next here Z for phase will be 1080 divided by 3, then what you are going to get, that is 360. Okay. Number of turns per phase means you are going to get, that will be, that is equals to, so Z phase divided by 2, that is equals to 180. Now, you got turns per phase. Next, n is equals to number of slots per pole, number of slots per pole, you are going to get the number of slots per pole is, you are going to get it as, that is equals to 90 divided by 6. So, that will be 15, right. So, we require all these things, and ns is equals to it is given the synchronous speed is equals to 120 f by p, but frequency is not given. Frequency can be p into ns divided by 120, that is equals to number of poles are 6 and ns is equals to 1000, it is rotating, divided by 120. Frequency you are going to get it as 50 Hz. Now he is asking, and kp value it is, because it is full pitch you can consider it as 1, and kd value it is given as 0.97. So, because it is a full pitch, we are consider kp value is or kc value we are considering it as 1 value. So, kd value we are going to get as, that is 0.97. Now, we will calculate what is the EMF per phase. See, EMF per phase you have to consider, that is equals to, we can write E per phase is equals to 4.44 into kc into, that is kp into kd into phi f t per phase, phi f t phase. So, let us substitute that 4.44 into, that is 4.44 into kp value you are going to get that is 1, next kd value is 0.97 and flux per pole is 0.5 Webers and frequency is 50 Hz. Next it is t per phase. See, here t per phase is 180 you got. So, you have to substitute that also 180. So, final answer you are going to get it as, that will be E phase value you are going to get it as 19380.6 volts. Okay, that is next line voltage is equals to, you have to multiply with root 3 times, because it is a star connected, that will be 563.18 volts. So, how you are getting phase value, that is root 3 times of E phase. So, you have to multiply root 3 into 19380.6 volts. So, if you got this answer, your all problems are correct, then you will get the full marks. That is all in this video. If you like this video, please like, share and subscribe the channel. If you have any query, please make comment in the comment box. I can reply. Thank you very much.